To begin looking at the bones and joints of the hand, let's see what they're called. Here are the 8 carpal bones, and here are the 5 metacarpals. Each finger has a proximal phalanx, a middle phalanx, and a distal phalanx. The thumb just has 2 phalanges, a proximal phalanx and a distal phalanx. The joints of the hand have long names. The joints between the carpus and the metacarpals are the carpo-metacarpal joints. The joints between the metacarpals and the proximal phalanges are the metacarpophalangeal joints. The joints between the phalanges are the interphalangeal joints, proximal and distal. We'll often refer to these joints as CMC joints, MP joints, and IP joints for short. To look in some detail at the bones and joints of the hand, we'll look first at the carpus, then at the 4 fingers with their metacarpals, then at the thumb with its metacarpal. We saw the individual names of the carpal bones in the previous section. Let's look at their overall shape. There are 2 bony projections on each side. On the ulnar side, the pisiform bone, and this part of the hamate, called the hook. On the radial side, the tubercle of the scaphoid, and the crest of the trapezium. With these projections, the bones of the carpus form the base and the side walls of a space called the carpal tunnel. Here's how the carpus looks in the living body. The radiocarpal and midcarpal joints are hidden by the heavy capsular ligaments. Here are those 4 projections again: the tubercle of the scaphoid, the crest of the trapezium, the pisiform, and the hook of the hamate. And here's the carpal tunnel, still without its roof. Now let's move on to look at the metacarpals of the 4 fingers and at their CMC joints. Here are the carpo-metacarpal joints. The bases of the 4 finger metacarpals, tightly packed together, articulate here with the distal row of carpal bones. The base of the first metacarpal, the one for the thumb, articulates separately here with the trapezium. These 4 carpo-metacarpal joints only allow a small amount of movement. The 5th metacarpal is the most mobile, the 4th is less so, the 3rd hardly moves at all, and neither does the 2nd. When the CMC joints are flexed, the metacarpal heads lie in a curve. This strong ligament is the deep transverse metacarpal ligament. It keeps the metacarpal heads of the 4 fingers from spreading apart. As it crosses each MP joint, the ligament is continuous with a structure that we'll meet shortly, the palmar plate. Since it doesn't connect to the first metacarpal, the ligament doesn't prevent movement of the thumb away from the hand. We've looked at the bones and joints of the hand and at the movements they're capable of. Before we move on to look at the muscles which move the fingers and thumb and the tendons by which they act, there are a number of important pulleys and sliding structures that we need to understand. These structures guide the direction of pull of the tendons as they cross the wrist joint and pass along the fingers. We'll look first at the 2 big pulleys at the wrist, the flexor retinaculum and the extensor retinaculum. Here's the flexor retinaculum. It's a tough, unyielding strap of fibrous tissue. The flexor retinaculum is the structure that forms the roof of the carpal tunnel. It's attached on the radial side to the scaphoid and the trapezium, and on the ulnar side to the pisiform bone and the hook of the hamate. As we'll see, the median nerve and all the flexor tendons to the fingers and thumb go through the carpal tunnel. The flexor retinaculum branches off in 2 places, here and here, to enclose 2 small separate tunnels. This one, on the radial side, encloses the tendon of flexor carpi radialis. This one, superficial and on the ulnar side, encloses the ulnar artery and nerve. We'll be returning to the flexor retinaculum later to look at some important structures that arise from it, the palmar aponeurosis and some of the thenar and hypothenar muscles. Let's go round now to the dorsal aspect of the wrist to see the other big pulley, the extensor retinaculum. It runs obliquely from this ridge on the radius to the ulnar styloid, the triquetrum, and the hamate. The extensor retinaculum has a number of deep extensions which are attached to the underlying radius. These divide the space under the retinaculum into several small separate tunnels. All three wrist extensors and all the extensor tendons to the fingers and thumb pass under the extensor retinaculum. Now let's look at the structures in the fingers and in the thumb which hold the flexor and extensor tendons in place, allow them to move, and guide their direction of pull. In each finger, this structure, the flexor tendon sheath, provides the two flexor tendons with a smoothly lined, tightly enclosing tunnel to run in. The sheath starts just proximal to the MP joint and extends all the way to the distal phalanx. To see the sheath better, we'll divide it. Parts of the sheath are thick and fibrous, and parts of it are thin and collapsible. On this finger, we'll remove the thin parts of the sheath and just leave the thick parts. These act as pulleys for the flexor tendons, as we'll see. At each joint, the sheath is attached to the edge of the palmar plate. Between the joints, the sheath is attached along each phalanx. The floor of the tunnel for the flexor tendons is formed by the palmar plates and by the smooth, flattened surfaces of the phalanges. The thumb has a similar flexor tendon sheath for its one long flexor tendon. The arrangement for the extensor tendon is entirely different and quite complex. On each finger, the extensor tendon and the tendons of three intrinsic muscles come together to form a structure called the extensor mechanism. Let's take a look at it. We'll look at the muscles themselves a little later. So that we can see the extensor mechanism from all sides, we'll look at one finger in isolation. Here's the extensor tendon approaching the back of the MP joint. Here, both on the radial side and on the ulnar side, is the tendon of one of the interosseous muscles. In addition, here, on the radial side only, is the tendon of a lumbrical muscle. On each side, a triangular sheet of tendinous tissue fans out and connects the extensor tendon to the interosseous tendon. This triangular sheet is called the extensor hood. The big extensor tendon divides into three slips over the proximal phalanx. The central slip crosses the proximal IP joint and inserts here, on the base of the middle phalanx. The slips on each side fuse with the interosseous tendon to form the two lateral bands. The lateral bands join together over the middle phalanx and insert here, on the base of the distal phalanx. The thumb doesn't have such a complex extensor mechanism. The insertion of its two extensor tendons is relatively simple, as we'll see. One last structure to look at before we move on to muscles is the palmar fascia, or palmar aponeurosis. It's a dense triangular sheet of fibrous tissue which covers the middle part of the palm of the hand. Proximally, it's continuous with the flexor retinaculum and with the tendon of palmaris longus. Distally, it separates into slips, which insert into the edges of the palmar plates of the MP joints. The palmar fascia protects the underlying nerves, tendons, and vessels from harm. The skin of the palm of the hand is firmly attached to it. Flexion of the fingers is produced by two long muscles, flexor digitorum profundus and flexor digitorum superficialis. Here's the deep finger flexor, flexor digitorum profundus. It arises from the anterior and medial surface of the ulna and from the interosseous membrane. Here are its four tendons, entering the carpal tunnel, We'll follow them in a minute. This adjoining muscle we'll see later on. It's flexor pollicis longus, the long thumb flexor. Now let's add the superficial finger flexor, flexor digitorum superficialis, to the picture. Here it is. It lies right on top of the profundus. It has two heads of origin, a radial head and a humero-ulnar head. The humero-ulnar head arises as part of the common flexor tendon from the medial epicondyle of the humerus and also from the adjoining ulna. Its radial head arises from this long oblique line on the radius. Between the two heads, there's a gap which the median nerve and the ulnar artery both pass through. The four separate tendons of flexor digitorum superficialis are bundled together as they enter the carpal tunnel. Before we follow the superficialis and profundus tendons into the hand, we'll bring the forearm to the upright position. As the flexor tendons pass through the carpal tunnel, they're all enfolded within this common synovial sheath, which extends into the palm of the hand. Just as the flexor tendons emerge from the carpal tunnel, the four profundus tendons give rise to these four intrinsic muscles, the lumbricals. We'll be looking at these later. For now, we'll remove them to simplify the picture. Just before reaching the MP joint, the superficialis and profundus tendons of each finger enter the flexor tendon sheath together. To follow them, we'll remove the sheath. Over the proximal phalanx, the superficialis tendon splits into two halves, which pass around the profundus tendon. We'll remove the profundus tendon for a moment. The two halves of the superficialis tendon reunite, and as they do so, they insert here, on the middle phalanx. The profundus tendon, here it is back in place, emerges between the two halves of superficialis and continues distally to insert here, on the base of the distal phalanx. The action of flexor digitorum superficialis is to flex the proximal IP joint and the MP joint. The action of flexor digitorum profundus is to flex both the IP joints and the MP joint.